So let's put aside the vacuum tubes for a moment. Let's do MOSFETs now. I had in mind this coil since some time, and I want to remake my first Tesla coil that I made years ago, but this time improved and simplified. In fact, this thing is quite simple, although it uses an H-bridge as driver. This thing doesn't have gate driving ECs, it doesn't have PLL, microcontrollers, and logic ECs, almost at all logic ECs, because there's the staccato controller that is optional anyways. And the point is that I invented, let's say, a circuit, this one here. This circuit is the interrupter system for the coil and also the starting system for the engine of the coil. The engine of the coil is composed of the primary, the H-bridge here with these 4 MOSFETs you see. These MOSFETs are used, taken from computer UPSs. These are low voltage, high current MOSFETs, and they are rated for like 60 volts, but I characterize them to be 69 volts or kind. And the engine is also the gate driving transformer here with this voltage limiting system here that I'll show you in a moment in the schematic. And the gate driving transformer is driven on a winding directly from the bottom of the secondary. This engine can't start by itself, because although you provide the voltage to it, anything will be still. The secondary will be still, and the voltage on the gates of the MOSFETs will be 0. So, to start this engine, I have this circuit here. Sorry, I had to breathe. This circuit provides a DC current on a winding of this transformer here, and this DC current is cut abruptly when the set point voltage is reached on the supply line. And this cut of this DC current starts an oscillation on the engine of the coil, and it starts the engine, and the coil will then oscillate by itself once the current on this winding is cut, and the winding is also free to oscillate thanks to this MOSFET diode, resistor, etc. And I'll show you this in a moment in the schematic. So let's try stage 1. Stage 1 means just 2 MOSFETs in half bridge mode, so not full bridge. The other side of the driver is these 2 capacitors here. These 2 capacitors are put in series on the supply of the circuit, and the middle of the 2 capacitors go to the coil, to the primary of the coil. Anyways, I recorded this video beforehand, before making the full bridge, to show you the half bridge operation. And anyways, let's see how it works. So this is with the staccato controller here, it's flashing. Let's try. Let's adjust the staccato set point, lower, making also sword-like sparks, but not longer, sadly. If I set it to the edge, it makes slightly longer sparks. Sadly, I can't ramp this coil, I don't know why. Camera sync effect, sadly. Ouch! It slightly hurts. Okay. So again, stage 1 with just 2 MOSFETs, but this time without the staccato controller, so full 50 Hz. Sorry for this giant transformer for the staccato, it's the 10 volts transformer that I have now, it's an overkill. Anyways, let's try. Ow! Lower set point. Edge set point. It stutters because we are on the edge of the 60 volts ramp, peak 60 volts, and so it sometimes doesn't reach the required voltage to trigger. Anyways, so now let's try stage 2. Stage 2 is the full H bridge with the 4 MOSFETs, but now I couldn't use a single top load, a single, let's say, small top load, because although I consider this top load gorgeous, I made it myself, it's not enough because I had to use a bigger top load. Why? Because a bigger top load not only lowers the resonant frequency, that is a good thing for SSTCs, now we are at like 240 kHz, not only makes the resonant frequency more stable and more definite, but also it increases the backing effect on the bottom of the secondary to drive the gate driving transformer harder, because apparently 4 MOSFETs are harder to be driven than just 2. Anyways, now the coil makes sparks of 20 centimeters of length, touching 20 centimeters, and I can't ramp this coil, sadly, making sword-like sparks. The sparks are quite branched. Why? Because the current here, the current drawn is so high that I can't base myself on this big transformer, this big 40 volts transformer, because you need to base yourself on these capacitors, on the charge of these two capacitors that are in parallel now. And these capacitors are polypropylene, rated for mains voltage, and you can find these like in hardware stores. These are easy to find and fairly cheap also. So let's try it now in H-bridge mode, full bridge as you call it. Ok, 12 volt supply on, staccato controller on, and power. A bit of pause to let the camera sync roll because the spark is synced with mains and the video is 30 Hz, the coil is let's say 50 Hz, and sometimes the frame is synced on the first part of the spark and the last part of the spark doesn't come up on the video, so let's try again. And I think that this effect is happening. Let's wait a bit. Now it's better. Okay, as I said, the spark length is touching the 20 centimeters. Now we have 48 volts out of this transformer, 48 volts SC. Adjusted a bit with my variac, just a bit more of juice. Okay, now let's try it again with the H-bridge, full bridge as you call it, but without the staccato controller, so full 50 Hz. This transformer has no use. Let's give the 12 volt supply again and power. I don't want to overheat the coil, especially these ziners here, so I give just shots of power, because I don't know what could happen, because this thing is a bit extreme, especially in terms of current, peak current. Okay, and so here's the schematic of the coil. And also the schematic of the staccato controller here. And anyways, you'll find these same schematics in the description of the video below. And if there is an update for this coil, you'll find it also in the description of the video. And this coil came up so simple that it was possible to simulate the entire coil, including secondary, H-bridge, anything, the interrupter system, gate driving transformer, except the optional staccato controller, simulate it in LT-Spice in my PC. The simple this coil is, and I warn you, this is not the schematic of the coil that you have to refer to. If I suggest to replicate this coil, well, yes, it's very simple in my opinion, made with trash. You can take the transformer out of an audio amplifier, like a 100 watts audio amplifier. You need a 40 volts transformer, and also this coil can be scaled up to be more powerful using like high voltage IGBTs. These are 600 volts low current, and these instead are serious IGBTs that I intend to use someday, I don't know, anyways. And also this coil is already, with these low voltage MOSFETs, in my opinion, more powerful than a Scori Tifatronics old style low voltage SSTC. In my opinion, this is more powerful. So thanks for having watched my video, and bye!